We'll be spending some time talking about certain phenomena that we see as a result of intermolecular forces. The first of which that we're going to talk about is surface tension. Now, you have observed surface tension when you see a water strider walking along the surface of a liquid without actually falling in. Or sometimes you'd notice that water tends to form droplets um, on, say, a leaf, or that the way a lava lamp moves, the liquid in the lava lamp moves. These are all as a result of surface tension. And this surface tension is due to the fact that a molecule in the bulk of a liquid experiences cohesive forces with other molecules in all directions, whereas at the surface of the molecule interacts less and only observe or experience inward cohesive forces. The difference between these adhesive and cohesive forces determine the behavior of the liquid in contact with the solid. Now, intermolecular forces are also responsible for viscosity, and viscosity describes resistance to flow. And so you call, say, honey and, say, molasses to be highly viscous solutions because they are highly resistant to flow. The higher the intermolecular forces, the higher the viscosity because it keeps the molecules attracted to each other. If you look at a table showing alkanes, you realize that as you increase the size of the alkane, then the viscosity increases because the intermolecular force increases as well. Now, you can also see intermolecular forces when you talk about capillary action, which is the ability of a liquid to flow up a thin tube against the influence of gravity. The liquid rises up into the tube until the force of gravity counteracts the capillary action forces. The narrower the tube diameter, the higher the liquid will rise up the tube. Now, vaporization is another situation under which you see intermolecular forces. Because molecules in a liquid are in constant motion, some of the molecules have more kinetic energy and others have less. If these high energy molecules are at the surface, they have enough energy to overcome the attractive forces, and this allows them to escape the liquid and become vapor. Now, these high energy molecules will be in the vapor state. Now, the opposite of vaporization is condensation, and it describes a state in which these high energy molecules collide with each other to return into the liquid state. Now, when you have condensation and vaporization occurring at an equal rate, we say that the system is in dynamic equilibrium. This does not mean that we have equal amounts of vapor and liquid, but it means that they are changing by equal amounts. And so, in dynamic equilibrium, the rate of evaporation is equal to the rate of condensation. The other situation that we would like to talk about is vapor pressure. The vapor pressure is described as the pressure exerted by a vapor that is in dynamic equilibrium with its liquid. So, the higher the vapor pressure, the more volatile the liquid. Boiling point. When the temperature of a liquid reaches a point where vapor pressure is the same as the external pressure, then you have vapor bubbles that are being formed from anywhere in the liquid, not just on the surface. This phenomenon is what we call boiling. And this is the temperature at which the vapor pressure equals the external pressure. This temperature is called the boiling point.